This lesson is about finding the prime factors of a number and expressing that number as a product of its prime factors. All whole numbers can be shown as a product of factors. For example, 15 is 3 times 5, 27 is 3 times 9. Some numbers can be shown as products of factors in more than one way. So 15 is also 1 times 15, and 27 is also 1 times 27. A number with exactly two factors is a prime number. The first prime number is 2, and that's 1 times 2. 3 is also prime, but 4 is not prime because 4 can be written as 1 times 4 or 2 times 2. So the number 4 has three factors, which are 1, 2 and 4, but the number 2 has only two factors, 1 and 2, and the number 3 has only two factors, which are 1 and 3. Sometimes there's a bit of confusion over the number 1. Is it prime or not? Some confusion has arisen because there used to be a definition of prime numbers which was it's divisible by 1 and itself, which clearly applies to 1. It's divisible by 1 and it's divisible by itself, but it only has one factor, and so it is not prime. It's a special number because it's not prime and it's also not composite. Composite is the word we use for a number with more than two factors. So 15, 27 and 4 are all composite, 2 and 3 are prime, and 1 is a special number which is neither prime nor composite. Now every single whole number can be written as a product of prime factors, except for that special case. I'm going to show you how to do that with these two numbers, 24 and 30. We start with the number that we want to factorise and write it as a product of factors, any factors. I happen to know that 24 is 4 times 6, so I'll start with that. Now, as we already established, 4 is not prime because 4 can be written as 2 times 2. 6 is also not prime. It can be written as 2 times 3. So I'll now go to one more level. 4 is 2 times 2, and 6 is 2 times 3. And 2 times 2 times 2 times 3 is 24. This is now a product of prime factors because 2 and 3 are both prime. And I can go one more step, which is to write it in index form. 2 times 2 times 2 is 2 cubed multiplied by 3. So this is now writing 24 as a product of prime factors. Now imagine you didn't know that 24 was 4 times 6. It doesn't matter where you start as long as you start with a product of factors. So you might realise that 24 is 2 times 12, so we'll start with that. 2 is prime, so that's fine, and 12 is 3 times 4. Or you might put 2 times 6. It doesn't matter, as long as you keep going until all of your numbers are prime. So now we've got 2 times 3, which are both prime, and 4, which is 2 times 2. So this is exactly the same as before. 2 times 2 times 2 times 3 is the same as 2 times 3 times 2 times 2. And I can still simplify this using indices. What we actually find is that every number can be written as a unique product of prime factors. There's only one way to express 24 as a product of prime factors, and that's 2 cubed times 3. So we can insert the word unique here. Now let's try 30, and I encourage you to pause the video at this point, try it for yourself, and then have a look at my solution. So 30 is 5 times 6, 5 is a prime number, and 6 is 2 times 3. So there's my product of prime factors. Or you might have started with 30 is 3 times 10, 3 is prime, and 10 is 2 times 5. As long as you've got these three prime factors, then you have expressed 30 as a product of prime factors.